Hi everyone, this is question number 33 in chapter 2. A hemispherical bowl of radius r cm is filled with water to a depth of h cm. So over here we have the base radius r cm, and this bowl is hemispherical in shape. So if this is r, this is also r. Okay, and the depth of the water is h. Okay. And let's look at what other information that we have. Now, the volume of the water in a bowl is given by this. Okay, we have to show that the radius of the water surface, which is the R, is given by this. Now, how do we do this part? In order for us to find the R, draw another line that joins from the center of the hemispherical bowl to the end of this part that join with the radius of the water surface. So over here, we will have the right angle triangle, whereby the line that I just drawn is the radius of the hemispherical bowl. Okay, let's just take that triangle out. So we know that this is R, this is small r, and this side will be R minus h, because this whole thing is actually the radius of the sphere, and therefore this part of the height of the triangle is actually r minus the h. So with that, we can find r. So r squared basically is the capital R squared minus the square of r minus h. Expand, so r squared minus 2rh plus h squared. Open up the round bracket, so r squared minus r squared plus 2rh minus h squared, and therefore we just proved that r is equivalent to square root of 2rh minus h squared. So we have just shown. Okay, let's look at question B. Water is poured into the bowl at the constant rate of 300 cm cubic per minute. So from here, we know that this question is related to rate of change. So the rate of change in volume, dV by dt, is equivalent to 300 cm cube per minute. And we need to find, in terms of R, the rate of change of the water surface area. So we're looking for dA by dt when 2H equals to R. So when we want to find the rate of change in one quantity, we split that into two parts and chain it together by the information that we have. In this case, it's dV by dt. So we chain this two with dV. Now, the question is, how do I relate A with the V? We are given that V is equivalent to this. So we can, I think we can relate the A, write A in terms of either H or R. So in this case, I think we differentiate in terms of R. So we split this again. TA by dV, so chain them together by dH. Now this one we don't have, but can be found our owner. All right, why do I choose H? Because R can be replaced with 2H, and the small r here is also written in terms of the R and the H. So with that, I shall form the equation of A equals to pi r squared. This is the surface area of the water surface. And then the R squared basically is 2RH minus H squared. And then we should replace the R with 2H. So pi R is 2H, so 2H multiplied with the remainder 2H, we have 4H squared minus h squared. So over here we have 3h squared, so 3 pi h squared. Then we can find dA by dH, that is 6 pi h. So we found the dA by dH, 6 pi h, and then dH by dV. So now we have to find V. Okay, V is given pi over 3 and then times 3r h squared minus h cubed. So we replace the r with 2h. So pi over 3 times 2h times with h squared and then minus h cubed. So we will have pi over 3. We have 6h cubed minus h cubed. Therefore, we have 5 pi h cubed over 3. So dV by dH will be 5 pi h squared. So we found dV by dH, but the one that we want to use is dH by dV. So write in its reciprocal, 1 over 5 pi h squared. And then multiply with dV by dt. dV by dt is 300, okay? And therefore we have 1 of the h simplified, pi simplified, 5 and 300 can be simplified, becomes 60. So we have 360 over h, and 2h equals to r. Therefore, h equals to r over 2, because the question wants us to give our answer in terms of r. So we shall replace the h with r over 2. So 360 divided by r over 2, we can write like this. Divide by r over 2, because I see fraction in fraction, so I write it like this, easier to calculate. So multiply, and then you change the fraction after the divide sign to multiply, and divide change to multiply. So the fraction after that we write in its reciprocal, so 2 over r. So the answer for part B in this question will be 720 over r cm squared per minute. That's it for this question.